and welcome to You Can Be a Doctor's UCAT preparation course for 2020. In this video we're going to be covering quantitative reasoning, which for some pupils can be their most dreaded section of the UCAT. For those of you who enjoy maths and are good with numbers, this can be quite an easy section, but hopefully you'll see by the end of this video that you don't necessarily have to be the best at maths to do well in this section. I'll show you just some of the questions that you might come up against in this section. Tables are very common in the exam, you'll definitely see them. You can also have questions from line graphs or bar charts or sometimes pie charts, so kind of figures like this. You can have questions that are purely based on text, which can be a wee bit challenging, and we've got one of those as an exercise. Or questions about time or time zones or about money and tax can come up, and we'll cover an example of both questions to just walk you through kind of the broad method for those. But first of all, we'll cover some tips. Now, the first tip I have for this section is to triage questions. And you'll hear me talking about this for the whole exam, but it is important in quantitative reasoning for a few reasons. This is important in quantitative reasoning because the questions can vary a lot in how many calculations are required to get to an answer, how many questions there are associated with a particular figure. You can have a really complicated table, but it's only got one question associated with it, whereas maybe a simple line graph can have 4 questions associated with it. And remember, each question is only worth 1 mark, so it might be better spending your time on graphs or figures that have more questions associated with them. You should also have an awareness of which types of questions you struggle with. And so if you know that you don't do well with time, or it takes you a long time to work out tax, then in the final exam, you should just guess an answer and then skip those and come back to them at the end so that you're doing the other questions first. And again, getting as many marks as you can. There's also a few formulae and relationships that are useful to understand for the quantitative reasoning section. Some people will say that the maths in the UCAT is set at a National 5 or a GCSE level of maths. And this might be correct, but I think that's a bit misleading because there are many subjects that are included at that level of maths that won't be in your exam. So I think it's much more important to just focus on the common relationships that come up a lot, which you can see on the screen here. Percentages come up all the time. Speed, distance, time is quite common. Some geometry, so area of 4-sided shapes is common, area of circles sometimes. But just understanding these relationships is really important. And understanding is the key word because oftentimes these formulas are given in the questions where it's relevant. It might not be necessary to memorize them, but the questions will be asking you to reverse these formulae and asking you to work out the length of a side based on an area and things like that. So actually understanding how these formulas work are key to using them well in the quantitative reasoning. Now, you'll all know that you have your noteboard and your whiteboard pen during the exam, and that can be really handy during quantitative reasoning because you can imagine that if you're calculating some figures, in later questions, you might be using those same figures as part of a calculation. So to save you having to recalculate them, if you've noted them down on your board, you can just refer back to that. And it can also be useful for rearranging formula if you have to do that for a question or for drawing out shapes. Finally, it can be useful to read the final question before you dig deep into a figure or into a table. And we'll see this in the exercises, is that oftentimes a question doesn't need all of the data to be answered. So unlike in verbal reasoning where I advised you against this, it might actually be useful to look at the final question before you look at the rest of the information. And now for some things that you might come up against. Everybody hates the calculator. If you're not familiar with it yet, you will be. You have to click on a button and it brings up a calculator that you use completely on the screen. So whether you're taking this at home or at a test center, you cannot use a physical calculator and you definitely can't use a scientific calculator. You will need the calculator for some questions, and I would advise you to get comfortable with it and use it during your practice. However, you should also have confidence that you can use your mental maths and do a lot of the calculations in your head, which will save you time having to click on the calculator. Then, just take care that you're working in the correct orders of magnitude and units, because oftentimes you'll be presented with information that has maybe had the thousands taken off it, or you'll be comparing distances that aren't in the same unit of measurement, for example. So before you start doing a calculation, just make sure that all of your numbers are in the same format. As for decision making, there isn't one approach that works for all types of questions because there's just so many different types that can come up. So we'll go straight onto some exercises. And this first one is a question containing a table. This table looks really complicated. What I want you to do is have a look at this table and see if you can understand what is being shown by each column and see if you can understand how the data in each column relates to each other. So pause the video now. So for those of you who paused, had a look at the table, I hope you managed to kind of dig into the figures there. We can see that the second column here shows the total audience for a particular program. The third and fourth columns here show how many of that audience is tuned in through specific services. You can see network and cable here. And then the fourth and fifth columns also show the number of people tuned in, but it's measured using a different metric. You can see there it's ratings. And the hint for this is the formula at the bottom, which tells us a way to transfer between ratings and numbers of audience. And I'll just show you calculation there. We can convert the 1.6 using this formula, quickly just rearrange it so that we have the number tuned in on one side of the equals sign. And then using the total audience for that program, we can calculate a figure for the number tuned in using Cindy's, whatever that is, and that gives us 168. So what I hope you saw when you were looking at this table while you were paused is that columns 3 through 6 show the same information, but just in slightly different forms. But we'll come on to the question now. So this question is asking about the percentage share of total viewers that program 5 has. So obviously we can see it's program 5 only that we're asking about, so that means that we're looking at this row on the table and we can ignore the rest of the data. It's then asking what proportion of the total audience it has. And so again, we can see that that relates to this column here. And that means that all of the information we need to answer this question comes from this first column. So we can ignore the rest of it to get our mark. This then becomes a simple calculation where we just need to take the number for program 5 and then divide that by the total audience. So you can see this calculation here shows finding the total audience, which is 37,775. We'll then divide 1,875 by that, and then that gives us our percentage, which is 4.96%. Answer B is the correct answer for this question. And now hopefully you can see how that demonstrates. You can be presented with very complex or quite dense information. It might be useful to actually read the final question first and see which parts of that information you'll need to get the mark. On to the next one. This is a tax question. I said money comes up a lot, and tax are some of the most complicated ways that money can come up in the UCAT. Again, the information is taken from a table. And I want you guys to look at this example of somebody who's earning £60,000 and see if you can work out how much income tax they would be paying. So pause the video now. So if you pause the video, give yourself a chance to go through this. If you were successful, you can just skip ahead in the video and see if you got the right answer. But if you struggled, then I'm going to go through this calculation in quite a lot of detail, and it might be excruciatingly boring, but I'll do this because understanding how to do these calculations can really help you speed up on these types of questions. I'm going to be using this kind of yellow working space just to show the calculations, and then this little yellow bar graph on the right is going to illustrate how income is taxed. So just watch both of them as we go through this calculation. So the person earns £60,000, which means that they're in the third tax bracket, which is here. However, they need to pay tax on each bracket up to their maximum. So we'll start at the first bracket there and see how much tax that is. So the tax rate is 10%. So they need to pay 10% of the income that falls within that bracket. So you can see that calculation there, 10% of 8,950, and that equals £895. We'll go into the next bracket. This is 15% this time, so you can take 15% of their income. But remember, they've already been taxed on the first 8,950 of their income, which you can see by that red bar there. So we need to take that away from 36,250, and what is left is the actual amount that gets taxed at 15%, and you can see that shown in this calculation here. So that's the second bit of their tax. To get the final bit of their tax, this is in the third bracket, which is at 25%, but remember they've only got 60,000, so we need to work out how much remaining income is left to tax, and we do that by taking what's already been taxed, which is 36,250, away from 60,000, and then finding 15% of that. So the third component of the tax that they pay is shown there on screen. That gives a total of 10,927 and 50p. So well done if you managed to get that on your own. But also if you're struggling with that, there are examples that come up in the question bank. So hopefully you'll be able to improve your speed of working with these questions. And for this question in particular, you can see that there's an extra bit on the side of the table where it actually does a few of the calculations for us. So for our example where this person was in the third tax bracket, we could skip doing these first two calculations, because that figure is given there. So this kind of running total allows us to just skip straight to the final calculation and then add on that 4,990 onto that figure. But we'll go on to the actual question for this exercise now. In this question, we are being asked about somebody who is paying a specific amount of tax, and we need to calculate what their income is. So this is what I was talking about before, where we have to reverse what we would normally do. So we're trying to calculate income from tax paid. This person is paying £4,000 in tax, which means that they fit into the second tax bracket, because you can see if they were paying more than 4,990, they would be in the third, but 4,000 puts them in the second bracket here. Remember, their tax comes in different components, so that £4,000 total is made up of 895 from the bracket before, which leaves 3,105 to be paid from that second bracket. And we can use this to calculate the income that they're paying tax on in the second bracket. So as is displayed here, that 3,105 is 15% of their total income that is in the second bracket. We can just quickly reverse this formula to give us the second bracket income, which is £20,700. And then all we need to do is add that to the top income from the first bracket, which is 8,950, which gives us their total income of 29,650, which means that answer C is the correct answer. So I've kind of taken you through two examples there where it's just the basic calculating how much tax somebody is paying, but then also a little more difficult question that you might be asked. It's important to do this kind of more difficult question because this was only 3 calculations. So once you're fast with these types of questions, you'll be able to fly through these in the exam. So hopefully you won't be put off. On to the next exercise. In this next exercise, we're going to look at a line graph. And I'm giving you this because it comes up fairly frequently in the exam, but also because this line graph in particular looks quite horrible. I want to see if you can figure out what each line means in this graph. And then I also want you to go on and attempt the question. So pause the video now. So if you paused the video, had a chance to look through the graph, maybe you also went on and did the question. I'm going to walk through the graph first of all, so we can see that it's made up of 3 lines. This first line is the median, and it's shown in that green there. Again, median is just a mathematical term. It's important to be comfortable with what these words mean, like mean, median, mode, or things like that, because they can come up in the exam. The next line is this red line, that dashed line, and that is the 5th percentile. And what that means is that only 5% of kids will be shorter than is given on this line. The dotted line shown here in blue is the 95th percentile. And again, what this means is that 5% of kids will be taller than this line at a given age. So essentially, between these 2 lines are where 90% of kids would reside. So 90% of kids, their height will fall within these 2 lines. But we'll go on to the question. The question in particular is asking about the tall boy line and the median line. So we can ignore the red line. And it's asking how old a tall kid would have to be the same height as a median kid at 3 years old. So a very simple question. We just need to go to where 3 years is, go up to the median line to find the height that we're working to. And then if we take that across, we can see that it's 96 centimeters. And then take that back across to see where the 95th percentile line, the blue line, would reach 96 centimeters, which we find around 28 months. Obviously, that means that answer E is the correct answer. Don't worry too much about the scale of this graph, because obviously it's very small. You might have thought that you have to get exactly on the line where this is, but if you look at the answers, you can see that answer E is the only one that is close enough to be the correct answer. So without looking at the scales, you could get to the right answer. On to exercise 4. Now this question is all about times and going between time zones. It's not very hard, but it can seem a little bit complicated the first time you come across these. So again, we'll go through a little method for them. What I want you to do though before we start is look at the text above that table. I want you to read it and just decide whether it contains any useful information that we'll use in any question that comes up. So pause the video now. If you pause the video and had a read, hopefully you'll have seen that in the text there's essentially no information that we don't already know. It's just describing how time zones work and talking about GMT. So none of that information is new and none of it is actually going to be useful for a question that comes up. Now, I wouldn't advise that you skip reading text in these sections, but what I want you to be aware of is if you read a section and decide that it doesn't contain any information, you can ignore that, and that means that the places where you're searching for information in your question is reduced, which again saves you time. So we'll get rid of this text and just leave us with the table and move on to the question. Now this question is asking about 2 people. One of them is in Vienna, one of them is in Chicago. and you can see that highlighted there. I just want you to be aware that the times given in the table are with respect to GMT. So they're not necessarily in the easiest format to be converting between these two times in Europe and in North America. So just be careful when you're doing your time calculations. Now, something that I said at the start was to make sure that all of your figures are in the same format before starting any calculations. And this goes for time as well. So what we want to do is get these two into the same time zone. Again, I'll bring up my working, and we're going to go from Chicago time into Vienna. From the table, we can see that Chicago is 7 hours behind Vienna, which means that 9:15 would be 4:15 in Vienna. So now we have both of our times on Viennese time, and the time difference between 8:30 in the morning, which was when the email was sent, and 4:15 is 7 hours 45 minutes, which means that answer C is correct. Now, one thing as well I want you to be aware of is these calculations were done in 24-hour time. And if you're not used to working in that, that can be something that's useful for the UCAT, because going over 12 p.m. where it goes back to 1 or 2 can complicate calculations. So if you're working from 0 to 24, that can make it a little bit clearer when you're going between different times. On to exercise 5. Now, this is a purely text-based question. There's no diagrams or tables to help you, but hopefully once you look at it, you can see that you can get to the answer quite quickly. And even if you can't get to the exact answer, you can give yourselves really good odds of guessing the correct answer. I want you guys to have a go at this question before I start. And I also want you to think about whether you actually need to do any calculations to get to the right answer for this question. So pause the video now. So if you pause the video, well done for having a go. Like I said, this question can look really complicated, but I'm going to walk you through my method for approaching it, and hopefully you'll pick up some pointers that you can take to other kind of more number theory text-based questions. If you understand geometry and how these values should change, so that's perimeter or area, you would easily be able to do this question without any working. However, I don't know for certain how the area should change. So how I approached this question was to exclude answers that couldn't be correct first. Again, I'll bring over my working pad, and what I'm going to show you is that we have two different parts of each answer. There's an area relationship, and then there's a perimeter relationship. For the area relationships, there's three different possibilities. It can be greater than, equal to, or less than. Whereas for the perimeter, there's only two different relationships, which is either that they're equal or that S is less than R. So I saw this initially, and that made me think that working on the perimeter first is going to be the fastest way to solve this question, because there's only two different options we need to exclude. So we'll start with working on perimeter. Then hopefully what you recognized is that shape S and R are four-sided shapes, and they're having 10 added to and 10 taken away from the lengths of their sides. So that means that the perimeter hasn't changed at all. And that's really useful, because that means that we can exclude answers C, D, and E. And if we stopped there, we could guess between A and B, and that'd be a 50-50 chance of getting the right answer. Within 30 seconds, we could have earned ourselves a mark. Now, obviously, we're going to go through the full answer. So now we need to think about the area and how's the area going to change. And like I said, if you know the number theory for this, you can easily tell how the number will change. But for me, I found it easiest to just go through some made up examples in my head. So you can see here a square that is 60 by 60. That would change to a rectangle that's 70 by 50. And you can see there how the areas change. The second area is lower. If we do another just little example in your head, this time with a square that is 80 by 80, you can see that when this rectangle is 90 by 70, that means that the area has gone down as well. So for me, that was enough justification to say that the area of the new shape is going to be less than the old one. So that means that answer A is the correct answer. So we've been through some exercises. I've shown you the common types of questions that can come up. And, you know, if you looked at the tax question and you found that really difficult, or maybe you looked at that last one we did that was all text and found that difficult, this first tip is going to help you out a lot. And that is, as I'll say over and over again, you need to be triaging the questions that are going to take up a lot of your time. This can be questions that are complicated, questions that have loads of calculations, or it can just be questions that you know that you'll struggle with. But either way, you need to be guessing an answer for those and then coming back to them at the end. You should get comfortable with the commonly used formulas and not only memorize them, but understand how they work so that then you can answer questions which ask you to reverse those equations. Use your notepad and don't be afraid to jot down numbers that you've calculated, or maybe use it to draw a diagram. Beware the calculator. It can suck up a lot of your time if you feel like you have to do all of the calculations in it. and be confident in your ability to do mental arithmetic. And then just make sure that all of your numbers are in the same format before you start doing a calculation, so that you're not combining meters and feet, or you're not working in two different time zones accidentally. Thanks for watching. I hope that video was helpful for your preparation. We do have videos covering the other sections of the UCAT if you're struggling with another one. And if you have any questions after watching our videos or reading our 2020 student handbook, then you can get in touch with us on our socials or via the email address listed there, and one of our medical students or doctors will get back to you with an answer. Good luck with the rest of your preparation.